Hello everyone. We continue with some more examples of trigonometry. In this example, you can observe a girl who's standing away from a chimney. The height of the girl is 1.5 meter. She is standing 28.5 meter away from the chimney, and the angle of elevation of the top of the chimney from her eyes is 45 degree. You need to find out the height of the chimney. Let us proceed to solve this. So AB is the height of the chimney. DC is the height of the girl, which means BE will also be the height of the girl. CB, which is already given 28.5, will be equal to DE, right? So in this right angle triangle ADE, we need to choose a trigonometric ratio which involves both AE and DE, because DE you already know and AE is what you need to find out. So which trigonometric ratio will you take? It is opposite side by adjacent. Yes, it is going to be tan 45 degree. So tan 45 degree is equal to AE by DE. Value of tan 45 is 1. Therefore, AE is also equal to 28.5. So AE is 28.5. The height of the tower is not AE, it is AB. So you will add the height of the girl, which is 1.5 meter. So the height of the chimney will become 30 meter. Next example. From a point P on the ground, the angle of elevation of the top of a 10 meter tall building, so this is the 10 meter tall building, this angle is 30 degree. A flag is hoisted at the top of the building, so DB is the flag which is hoisted, and from the same point P, this angle is 45 degree. You have to find the length of the flag staff and the distance of the building from point P. So how do we solve this? When you read the sum, line by line, you are supposed to construct the figure. So AB denotes the height of the building, BD is the flag staff, and P is the given point. So there are two right angle triangles, APB and PAD. So we are required to find the length of the flag staff, that is DB, and PA, which is the distance of the building from the point P. Since we know the height of the building AB, we will consider the right angle triangle PAB, because the height of the building is given. So tan 30 will be equal to AB by AP. The value of tan 30 is 1 by root 3. Therefore, AP is equal to 10 root 3. Now let us suppose this DB as x. So what will be the length of AD? It will be 10 plus x, because the height of the building is given is 10 meter. So your AD is equal to 10 plus x meter. So in right angle triangle PAD, the bigger triangle, tan 45 degree is equal to AD by AP, which is 10 plus x by 10 root 3, and value of tan 45 is 1. So you substitute the values and you find out x, which will be equal to 7.32. So the length of the flagstaff is 7.32 meter. Next example is of a 1.5 meter tall boy. You can see the tall boy over here. He is standing at some distance from a 30 meter tall building. This is a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. So he is walking towards the building. So initially the angle was 30 degree when he was looking up at the building. As he moved closer to the building, this from point C, the angle of elevation becomes 60 degree. So this is the figure. Let us see how to solve this. We have to find out the distance the boy covered towards the building. So we do not need ZY, we need to calculate XY. The distance the boy has travelled towards the building. He has not travelled up to point B. He has travelled only up to point C or point X. So, understanding the figure a little more closely, XY will be equal to CD. The height of the building is AZ, which is 30 meter. So, what will be your AB? Your AB will be your height of the building minus the height of the boy, which will be 28.5 meter. So, in right angle triangle ABD, so tan 30 will be equal to AB by BD. AB by BD. Please remember, you have to take the right angle triangle. Do not make the mistake of taking CD instead of BD, because the right angle triangle is ABD, it is not ACD. So it will be AB by BD. So you get the measurement of BD, which is 28.5 root 3 meter. Now again, in the right angle triangle ABC, your tan 60 will be equal to AB by BC. So from here you will get the length of BC. So BD minus BC, you will get your XY. So you will get BC from here. Once you get BC, subtract from BD, you will get the length of CD. CD will be equal to XY. Therefore, 57 by root 3 meter is the distance travelled by the boy towards the building. Next example, the angle of elevation of the top of a building from the foot of the tower is 30 degree and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, find the height of the building. So this is the figure. You have a building which is represented by line AB and the tower which is represented by line CD. The length of the tower is given 50 meter and the angle of elevation is given 30 degree and 60 degree. So from here you will find out what is the height of the building. So let the height of the building be AB and CD be the height of the tower. So you need tan 60 to find out CD by CB. CD is already given 50 meter. You will get CB from here. So tan 60 is equal to opposite by adjacent 50 meter by CB. So your CB is equal to 50 by root 3. Now you go to the triangle ABC. In triangle ABC, tan 30 will be equal to AB by CB. So 1 by root 3 is equal to AB by CB. CB you have already got 50 by root 3, which you will substitute. So we are substituting CB 50 by root 3 in the previous equation to find out the measurement of AB. AB is the height of the building. So once we get AB 16.67, that is the height of the building. Next example. From the top of a 7-meter high building, so this is a 7-meter high building, the angle of elevation of the top of a cable tower, this is the cable tower, from the top of this building to the top of the cable tower, this is the angle we are talking about, which is 60 degree. And the angle of depression to its foot, so from the roof of the building, when you are looking down, this is the angle 45. You have to determine the height of the tower. This is the height of the tower which you need to find out. Let AB be the height of the building, which is 7 meter. Now in the figure, EC is equal to ED plus DC. This is ED and this is DC. So you need complete EC to find out the height of the tower, which is divided into two parts, ED and DC, which are in two different right angle triangles. So you take first triangle ABC. So in this triangle ABC, this angle is 45 degree. So using tan 45 degree, you get AB by CB. Therefore, BC is also equal to 7. If BC is 7, your AD will also be 7. And in the triangle ADE, if AD is 7, you can find out DE. So your tan 60 degree will be equal to AE by AD. So your DE is 7 root 3 meter. So now EC is equal to ED plus DC. So you add both the sides. You will get the height of the tower, which is 19.12 meter. Now next example. As observed from the top of a 75-meter high lighthouse. So this is a 75-meter high lighthouse. The angle of depression from the top of two ships are 30 degree and 45 degree. So from the top when it is observed, so these are the angles 30 degree and 45 degree. There are two different ships. You can see the figure, there are two different ships, and from the lighthouse, top of the lighthouse, you are observing the ships. One is at 30 degree and the other one is at 45 degree angle. You need to find out what is the distance between the two ships. So AB is the lighthouse, the length AB is the length of the lighthouse, which is 75 meter. So we take the triangle ABC, we take tan 45 equals to AB by BC. So your BC is also equal to 75 meter. Now in triangle ABD, this big triangle you take, and this triangle also, you take tan 30, which will be AB by BD. So you will get your complete BD over here. Once you get BD, subtract BD from BC and you will get 54.9 meter, which is the distance between the two ships. Next question is a straight highway which leads to the foot of the tower. A man is standing on the top of the tower and is observing a car at an angle of depression of 30 degrees. As the car is approaching towards the tower, the angle at which it is approaching shifts from 30 degree to 60 degree. It was 30 degree initially, and as the car is approaching the foot of the tower from point D to point C, it comes down to 60 degree. So this is the figure. So AB is the tower. So this is the tower. D is the initial point and C is the final position of the car. So you can see the car is starting at point D and it is going up to point C. So D is the starting point and C is the final position of the car. So in triangle ABC, tan 60 degree will be equal to AB by BC. Substituting the value of tan 60, you will get AB is equal to root 3 BC. Now in triangle ABD, tan 30 is equal to AB by BD. So tan 30 is 1 by root 3. So AB is equal to BD by root 3. Now you are getting two values of AB. AB is equal to root 3 BC plus AB is also equal to BD by root 3. So we will try to find out the relationship between these two. So when we solve, we get we get 3 BC is equal to BD. So 3 BC is equal to BD, and what is BD? BD is BC plus CD, right? So BD is BC plus CD, which means we transfer this BC to the other side, we get 2 BC is equal to CD. So 2 BC is equal to CD. Here distance of BC is half of CD, right? Therefore, the time taken will also be half. The time taken by car to travel the distance CD is 6 seconds, which is given in the question. Hence, the time taken by the car to travel BC will be also half, that is 6 by 2, 3 seconds. Thank you, students. I'm sure you have understood these examples and you can use this to solve further examples given in the book. Thank you so much.